Today's video will demonstrate how to integrate the various components to the separation of concerns design patterns. Hello, I'm James Helfrich. The separation of concern design patterns separate a program into three components: storage, business logic, and interface. But how do you integrate those three components? Well, there are several different ways to do it. This video will explain each, as well as describe the pros and cons of them. Separation of concerns is the process of dividing the responsibilities of a class into three parts. The first part is the storage, and this is how data is represented in a class. The second is the business logic, and this is how the data is manipulated and the rules of the class. And the final is the interface, and this is how the client uses the class. Now, there are several different ways that I can integrate these different concerns. One of them is linear composition. The next is linear aggregation. The next is circular dependency. The next is ad hoc, and the final is model view controller. Let's take a look at each one of these in detail. First, linear composition integration is where the client communicates directly with the interface, which communicates with the business logic, which communicates with the storage. So we're going to have the linear composition integration, and the client's only going to see the interface, and the interface will then talk to the business logic, and the business logic will then talk to the storage. So as the name applies, we're going to use composition to connect these three concerns. So the interface will contain a business logic, and the business logic will contain a storage. This way, when I instantiate an interface, I automatically get a business logic and a storage, and the client doesn't have to do any work to hook things up. This is by far the easiest way to integrate the three concerns. The next is linear aggregation. And here the data flow diagram is going to look exactly the same as with linear composition, but the difference is going to be in the class diagram. Now notice how interface has a reference to the business logic, and the business logic has a reference to the storage. This means I can change the business logic or the storage on the fly, and it also means I can have more than one business logic working on a given storage, and I can even have more than one interface working on a given business logic. Now, the downside of this is it takes a little bit more work to connect these. In other words, if the client instantiates an interface, it does not automatically get a business logic and a storage. Those have to be hooked up separately. So a little more complexity, but a lot more flexibility. The next is circular integration. And this involves sending data from the interface to the business logic. And then the business logic then sends data to the storage. And then the storage then sends data to the interface. Now observe that if the business logic needs some storage data, it's going to have to go in a roundabout way to achieve it. Now notice that the storage will communicate directly with the interface without having to go to the business logic. The presumption, of course, is that any business logic will only operate on how data is stored, but not how data is utilized. Now, the class diagram is quite complex. The interface will have one reference to the business logic. And so when the interface needs to send data to the business logic, it just looks at its member variable. The business logic has one or more references to storage because we might be multiple storages involved. So if the business logic wants to save data, then it can do so, or even get data, it can do so. And the storage has a reference to, or more than one reference to, interface. And so if the storage wants to tell the interface that something changed, it can do so. Just like with linear aggregation, the client cannot just instantiate interface and expect everything to work. The client needs to hook up the business logic and the storage. The next is ad hoc integration. And this is where every component talks to every component. So if the storage wants to talk to the interface, then it can do so. If the storage wants to initiate a conversation with business logic, it can do so. If the business logic wants to tell something to interface, it can do so. Every component can talk to every other component. And there's a variety of different ways you can do it, but the simplest way is to make sure that every component talks to every other component with a reference. The final is the model view controller. Certainly the most recognized design pattern, however, probably the most misunderstood as well. Many people confuse model view controller with just separation of concerns and then use something simple like linear composition in order to integrate them. However, the interesting thing about model view controller is the storage communicates with the interface through the observer pattern. In other words, this is a composite design pattern. It's a pattern made after other design patterns. And so the class diagram reveals just how intricate this communication is. The view has a single reference to the controller, and the controller has a collection of views which it can talk to. And that means I can have multiple views operating on a single controller. There's a many-to-one relation there. Now, the controller also has a reference to the model. And so it can send data to the model and also receive data from the model. Now, if the model wants to make an update, it's going to iterate through all the different views that are subscribed to it, and that will allow the view to update its interface in reflection of how the data has changed. Now, which one of these is best for you? Well, it really depends on the complexity and the nature of your application. You can learn more about the different styles of integrating views in the Integrating Views section of the Separation of Concerns chapter of the Software Design textbook.